Well, what happens when outdoor air leaks into a building during the winter in many of the world's climates? Air leakage from outdoors is also known as infiltration. Unless the grains of moisture, which are drops of moisture, are added to this air, if the grains remain the same, relative humidity will be lowered. And we will explain that in just a second. Lots of people think heating systems dry out the air. Well, typically they do not dry out the air. But it'll be clear in a second why running a furnace in the winter, when you couple that with air infiltration, can actually lower your relative humidity. These are sources, and this comes from the government. This is an Energy Star graphic which shows air leaking into a house as blue arrows, and it shows air leaking out of a house, or any structure really, in red arrows at the top. There are lots of sources of air infiltration into a home or a place of business. This is a good example. We're going to look at 3 examples where we have outdoor air and indoor air at different temperatures. But we've kept the absolute humidity levels constant in each one of the examples. In other words, our outdoor air is 50 degrees dry bulb, and this is all Fahrenheit. 50 degrees Fahrenheit dry bulb is simply a plain old thermometer temperature. There's no humidity taken into account. And we also, for the outside air, have 45.3 degrees Fahrenheit wet bulb. That says percent. Sorry about that. That's a typo I didn't catch. That's 45.3 degrees Fahrenheit wet bulb. Well, that air sample, we've got 37.4 drops of moisture per pound of air. That's 37.4 grains. That then gives me a humidity, relative humidity, of 70%. Well, if I bring that air indoors, in other words, I allow that outside air to leak into my house or into my place of business, and I heat that air to 70 degrees, that 70-degree air would now have a 54.2 degree Fahrenheit wet bulb. And since I didn't change the grains, remember I said if you don't change the absolute humidity, if the drops of moisture or grains of moisture per pound stay the same, then look at our relative humidity, what happened to it on the right side. It started off outdoors at 70% relative humidity. It leaked into the building, was heated up to 70 degrees, and because I heated the air, it can now stand or contain much more moisture. So relatively speaking, the humidity went from 70% relative humidity outdoors. Once I brought it in and I heated it, the relative humidity went down to 34.3%. So the simple process of allowing that outside air at 50 degrees to leak into the building, and now we have to heat it up to 70 degrees, the relative humidity dropped. Not all that significantly, but it dropped by more than half. The next example shows 20-degree dry bulb. Now our outside is colder. We've got 17 degrees wet bulb, and we've got 8.9 grains of moisture per pound. And remember, a grain is roughly equivalent to a drop of moisture. Now my relative humidity is 59% under those changed outdoor conditions. But if I bring that air into the building and I heat that air to 70 degrees Fahrenheit, but I leave the grains unchanged, because simply bringing the moisture into the house is not going to change the grains. By leaving the grains unchanged, I now have 8.2% relative humidity. And that's simply the process of allowing that 20-degree air to come into the structure, and now I heat it up to 70 degrees. And the relative humidity drops because of the heat added to that air. And that is identical to the process that happens in your home or your place of business when 20-degree outside air is allowed to infiltrate to the indoors. So that's the process of how the humidity goes down when we operate our heating systems, because our heating systems are only going to operate when the outside temperature, in this case 20 degrees, is lower than our desired inside temperature. And this is an extreme case, almost what we're dealing with here in Lansing, Michigan today, where my outdoor air temperature is 5 degrees dry bulb, and my wet bulb temperature is 42 degrees Fahrenheit. Again, a typo. Sorry about that. Now my grains are 5.7 for that 5-degree outdoor air, and that gives me a relative humidity of 80%. So it might sound like if I allow that air to come into the structure, which I have to, because air is always going to leak into a building in different or at different rates. By allowing that air to come in, I have to heat it up so that the people will be comfortable. If they have their thermostat set at 70, I'll heat it to 70. Well, if the grains don't change, if the grains stay at 5.7, the humidity is going to go down once I heat that air up from 80% down to just 5.3% relative humidity. Now I'm in a condition where you will have all kinds of problems due to that low humidity level.